Good afternoon. Today, I'm going to discuss about the paper Predicting Autism Spectrum Disorder through Sentimental Analysis with Attention Mechanism, a deep learning approach. Here, the main aim was to predict the autism spectrum disorder with the help of deep learning process at the earliest. And now, what are all the contents actually we are going to see in this particular presentation? First thing is introduction. Second, literature survey. Third, methods. Next, fourth, experimental analysis. Fifth, results and discussion. And finally, conclusion. In the introduction, actually, the autism spectrum disorder. Actually, this disorder is a neurological and the developmental disorder. Actually, this affects the people with respect to communicate, learn, and the behavior. And currently, the statistics tells about nearly 1.5% of the global population have been affected by this autism. And also, another thing a study says, nearly 700% of the autism spectrum has been increased since 1996. The WHO report says nearly 1 in 100 people have this autism spectrum disorder. The overview of autism ASD. And here, it is a common and complex neurodevelopment disorder, and it can affect the individual throughout their lives. The main key characteristics are the communications and social interactions. They have challenges in social communication and social interactions, and the presence of restricted and repetitive behaviors. The importance of early diagnosis is it's a critical for timely and effective interventions. And mostly, it relies on neurological signals and behavior assessments. And no definitive biological markers or simple diagnostics procedures are currently exist in our in the present methods. And also, this makes our ASD diagnostics a challenging process. And the general practitioners of ASD is mainly rely on the ASD symptoms. And here, it is the crucial for timely supports and interventions. And it can also greatly enhance the quality of their life for individuals with ASD, and not only them, also their families. The machine learning and the deep learning advancement shows the promise in predicting ASDs with physical and psychological indicators. The overlapping symptoms with the other mental issues compliance the ASD is increasing false positive. And also, here we are understanding the models, features, and that also helps the healthcare professionals to make them informed about the decisions, enabling the early identifications and improve their treatment outcomes. Now, here we use the sentimental analysis and NLP techniques. It is an emerging novel method for predicting ASD by analyzing the linguistics and the emotional patterns in the communication, and also intelligent systems with attention mechanism also been used to process the extensive textual and auditory data for ASD predictions. Here, the attention mechanism improves the model focus on relevant cues and that enhance the accuracy for predicting the autism spectrum disorder. By utilizing the sentimental analysis and the attention mechanism, we can provide a tool for early detection of autism, and it will facilitate the timely inventions of predictions. Our research significance process towards a better future for individuals with ASD, and also it highlights the impact of intelligent systems in healthcare. And the NLP, also the natural learning process, the natural language process task, we employ the attention-based bidirectional long short-term memory, that is BiLSTM. Here we have combined the Adam optimizer with BiLSTM to execute or to predict the model more effectively and more precisely. This configuration form of a neural network architecture that optimizes the training and processes the sequence and focuses on the key input data for improving the accuracy. And here are the some of the literature survey, and also it is some of the important literature survey, and some of the author has been defined that with respect to autism spectrum disorder in a different manner. Raj S. and Mastood have detected the autism spectrum disorder in children, and they have used the machine learning algorithms for the non-clinical datasets, and they achieved 98.30% of the accuracy in SVM and CNN after handling the missing values. Murali, Anand and Kanchana identify the ASD in children by various ML techniques, and they have achieved 96% of the highest, 96% is the highest process of SVM. And Russia, the author proposed the enhanced CNN model to identify the autism spectrum disorder. And the author proposed the method with accuracy of 80% in pattern identifying with respect to anterior and posterior brain regional functions. The next author have presented the method to detect autism spectrum disorder on resonance imagations or as fMIR, the long-term memory, CNN and hybrid model were utilized by the author to identify the process, and the author achieved 74.74% accuracy and 72.92% of sensitivity in RNN-based model. And the next author proposed the hybrid deep learning model to detect the autism in, with respect to hybrid model consists of CNN with BiLSTM, and it classifies the output from EEG data. The next author achieved 97% accuracy with respect to the system, and it has been divided with 70-30% of training and testing. Here, the study highlights how VGG16 CNN, which outperformed, and they have achieved the results with increasing percentage. The next author detects and they classifies ASD data, and also they have compared 3 different models with SVM, KNN, and RF with pre-processed ABDI datasets. The next author diagnosed the image-based ASD from ABDI1 and ABDI2 datasets and the age group of 5 to 10, and they have proposed the CNN model with ADAMX optimizer. The next author supports the the SVM and random forest and multi-layer perceptron, CNN, and Navy Blaze and the deep learning network were among the techniques the author were used. And finally, 89% of the accuracy has been found by the random forest model. Here, the next process, methods. Here, how the data has been collected. The data collection is utilized by the web scraping techniques to gather the unstructured data from the internet. The unstructured data was next transformed to the metadata to store for storing and to analyzing in the database. The main focused on the large database from Twitter and to explore the social media conversations around the ASD. And here we have approached this approach aimed to understand the various individual perceptions and the behavior regarding the autism. The data was also collected by using the keywords and with respect to hashtags. Here, some of the hashtags have been included for the example, like autism, ASD, autist, autism acceptance, autism asking, autism parents, autism awareness, and World Autism Day. And these are all the examples of that have been included for web scraping and to find the appropriate data. And the next, the data from the Twitter. Here, the process is being conducted, how the data is being collected and how it has been processed. Here, from the Twitter, it has been taken and the Twitter API is used to collect the data, and with respect to the hashtag and the data has been stored in the process, and we are pre-processing the data with the help of some hypertext removals, stemmings, stop word removals, taggings, and lemmatization, and also some of the dictionary words with TF-IDE, n-grams. And finally, we have cleaned the data and it has been stored into the dataset. And here the model structures. Here we have used LSTM and bi-LSTM models. And this section, LSTM and bi-LSTM models have advanced from RNN used in the deep learning models. Here, the LSTM solves some of the traditional challenges, and also it is the introducing memory cell regulated with 3 gates: input, output, and forget gates. These gates manage the data with insertions, deletions, and the release from the memory cell, which allows the LSTM to selectively retain or discard the informations from in the LSTMs. In contrast to that LSTM, here we have proposed a bi-LSTM methods for input both forward and backward process. And it consists of 2 LSTM layers with enhanced context understandings. Here, the bidirectional process enables bi-LSTM to consider both past and future context to make the process intuitive and comprehensive temporal awarenesses. The next thing is attention mechanism. Here, this method also being used to predict the autism spectrum disorder. Here in the deep learning, it is been prioritized for the importance of the attention mechanism, and also it is used to improve the accuracy and the computational process very efficiently. And the next thing is n-BiLSTM with attention mechanism. Here, the model conducts sentimental analysis on text data, by identifying the specific patterns indicatively of sentimental related to ASD, and also utilizing an attention mechanism to prioritize significant words of the face. Here, once the data has been collected, it has been pre-processed with the help of n-gram feature extractions, and it has been fed into the bidirectional LSTM and then captures the context from both the past and the future words in the sentence. Fully connected layers often with activation functions connected to the final predictions through feature extraction from bi-LSTM and attention layers. The final output, it consists of a single neuron with sigmoid activation functions. It has been suitable for binary classifications. The model performance is evaluated by the following criteria, that is accuracy, precision, recall, and F1 score. Here, the experimental analysis, this section focused in the proposed system, and also it has been, the data has been around 1,000 from the Twitter, and also it has been searched by our Twitter API tool. And once it has been retrieved, it is divided into 80-20 ratio. 80 is for training and 20 is for testing. And the next thing is we have used the convolutional matrix to have the performance for true positive and true negative. To identify the efficiency of n-BiLSTM with the attention mechanism, the evaluations are calculated with respect to accuracy, precision, recall, and F1 score. And here we have the confusion matrix. And here the comparisons between the jaundice and autism. And here in the first part of the diagram, the confluence of gender. And the second thing is with respect to jaundice, the occurrences of jaundice in the male and female. The next thing, the occurrences of jaundice, and also if the jaundice has been occurred in the certain ratio, and there are possibilities of occurring in the autism in this particular streams. And the next thing is here, the proposed system was here. The proposed system was compared with 3 deep learning algorithms, namely CNN, LSTM, and BiLSTM. Here, we can clearly see that some of the models here, CNN model, LSTM model, BiLSTM model, and our proposed n-BiLSTM attention mechanism model. And here, for respect to accuracy, it has achieved 90%. With respect to precision, it has achieved 92%. With respect to recall, 95, and F1 score, 93%. And it is a comparison diagram for with various suggested algorithms. And here, with respect to ADAM optimizer, this is the proposed method. And in the proposed method of n-BiLSTM attention mechanism, the ADAM optimizer has secured the accuracy of the highest with respect to all the algorithms. The CNN, when it is comes to accuracy, it has reached 98%, and with precision, the highest score of 96, recall 97, and the F1 score of 97. And here is the training and validation loss diagram with respect to attention mechanism of ASD models and training and validation accuracy of n bidirectional attention models. Finally, the results and discussions. In this study, actually, we have proposed the n-BiLSTM attention mechanism for detecting analysis, and we have utilized the API, Twitter API, and the attention mechanism we have employed, and the accuracy rate has been achieved with 98%. Our proposed method with a ADAM optimizer has achieved the training accuracy of 98%, which is the highest percentage. And this is the comparison diagrams with respect to other authors, and we have achieved the highest percentage of 98 in all the comparison diagrams. And finally, we are concluding with this is the best n bidirectional attention mechanism. It's used to predict the autism spectrum disorder, and it has been integrated with the promising approach of early detections, and also we have achieved the impressive study with 98%.